the population in thousands, so we're doing this in thousands, of a rare bird species can be modeled by the exponential function f of x, shown below, where x represents the number of years after 2018. According to the model, how is the population of species anticipated to change from 2020 to 2030? Okay. So right away I can see that this function in itself is based off the year 2018. So at 2018, f of x is equal to 0. Okay? But we want to see what is it going to be between 2020 and 2030. So if it's starting at 2018, f of 2030 would be, oops, not 2013, 2030, keep writing that, 2030, take away 2018, would give you 12. And this is, since this is the calculator section, you don't even have to do that. So you get a 12. So f of, or 2030, is going to be f of 12. So if we do the same thing for f of 2020, well, we know 20 take away 18 gives you 2. So f of 2020 would give us a function at f of 2. We want to know how it's going to change, okay, between those 2 years. Next, let's kind of just see what this question is looking for now that we kind of dissected the entire thing above. It says, fill in the blanks with the correct phrases to make the statement true. The given model predicts the population of the rare bird species will increase or decrease. Well, this is based off the base. That number is less than 1, therefore, it's going to decrease. You can see that right away. It's going to decrease. And this is a drop-down question, so we need to make sure we get both parts right. So, easiest way to do that, let's just do this using the function. Let's find f of 12 first. So, we get, what is it? F of 12 is equal to 27.4 times the quantity of 0.972 to the power of 12 plus 15.9. Based off our order of operation, we're going to do what's in the parentheses with the exponent, then we're going to multiply it, then add at the end. So 0.972, you're going to click this button. I'll do it right over here. You press this button. That gives you the exponent. There we go. So again, 0.972 to the power of 12 times it by 27.4, and you get 15.9, and we get right here 35.387033396. You don't really have to write that all down. Since our information's in the thousands, so you multiply by 1,000, you get right away, based off this, it's going to be 35,387. That's about the answer. So that's it rounded. So we're going to take away from f of 2 now. F of 2 is equal to 27.4 times the quantity of 0.972 to the power of 2 plus 15.9. So just before I go any further, let me just keep myself organized. F of 12 is equal to 35,000. Now we're trying to find the f of 2. I'll just use this color. So again, we're going to do this with the calculator. I'll do it right here since it's on the glare. 0.972 to the power of 2 times 27.4 equals plus 15.9. And we get, this is equal to 41.7870816. But since, again, we're doing in the terms of thousands, we're going to multiply, like we did here, by 1,000. So we get roughly around 41787. So 41,787 for f of 2. So they want to see what is going to be our answer. So the way we do that, how did it change since it's decreasing? We're going to do 41,787 take away 35,387. So how is the bird population going to change after this? You just subtract it. You don't have to do this by hand because it's the calculator section. 41787 take away 35,387, and we get about 6,400. So it's roughly 6,400. So it's going to decrease by 6,400.